Welcome to the Finishing Touch podcast from Superfici America. I'm your host, Bret Johnson. Each episode, I sit down with experts in the automated finishing industry to talk coatings, try schedules, emerging trends, and practical tips. Whether you're an industry pro or just getting started as a new operator, this podcast has something for you. We're here to share insights, answer questions, and help you stay ahead in the world of automated finishing. Let's get into it. All right, guys, so on this episode, we're going to take a deep dive into the three bottlenecks of automated finishing. You basically are going to have sanding, spraying, and drying. So if we eliminate the bottleneck in one area, we're going to move it somewhere else. It's helpful to eliminate one of those three or two of those three, but it's most helpful to eliminate all of them if at all possible.
What are some signs that you may have a bottleneck?
Yeah, good question. So your work that's in progress could be piling up at a certain stage consistently. You realize we're getting through this process good, but then we get to this certain point and it's just, we hit a dead end road. Idle time between processes, customer delivery delays when you're proficient in other areas, but you're not meeting deadlines, all signs of bottlenecks. So I guess let's break down each of these in detail. So we'll start off with sanding. So you've got whitewood sanding, and then you're going to have your inner coat sanding, right? Your primer or your sealer sanding. So your whitewood sanding, you're going to be prepping your raw wood. So you're going to be taking your raw wood substrate, and you're going to be sanding it, trying to remove imperfections, trying to smooth the surface, trying to create some mechanical adhesion for that primer coat to go onto it. And then you're also going to have your primer or your sealer sanding or your inner coat sanding right before your final coats.
So you got to sand more than once?
Yeah. That's, believe it or not, you gotta sand every time. Typically, there are some situations in coatings where if it's within a recoat window, you don't have to do the sanding because you'll get chemical adhesion. But a lot of times, it's even in those scenarios, it's best if you can let it dry and then sand it. Right, you're gonna get the best results. So.
We have many different types of sanders. Would you explain a couple of them?
Yeah, man. So the first is going to be wide belt sanders. On a flat line where you're running parts, relatively flat parts on a belt, they're going to go through, and these wide belt sanders have just that. They're wide belts, and they're going to be sanding those flat parts. So the belts are going to be moving like so, and then the parts are going to go through, and they're going to sand them. In our machines, just for example, like here in the lab, all of these are modular machines, so you can have as many heads in these sanders as you want. So, like our whitewood, what we call our calibrator wide belt sander, here in the lab, it has our first head is a steel drum. It's a calibrator head, and it's going to have a really low coarse grid on it, so it's going to actually be removing stock and calibrating that board and making it true all the way around. So it's the same, width or thickness all the way around. And then we're going to move on to two rubber drums and then a super finish pad. So there's 4 heads in this wide belt machine, but we can customize them, different drum hardnesses, different configurations to do different things. So then we've got what are known as profile sanders, or edge. So you've got edge sanders. Typically this is for moldings and trim and or parts that you really want to sand and edge. You have a dedicated edge sander on it, usually skinny, long pieces, majority of the time. And then we've got orbital sanders. We've got planetary sanders. So these are heads that are made to remove swirl marks. Your planetary is typically designed to remove cross grain scratches that are actually put into the wood by those wide belt sanders. So a lot of times you'll have your regular wide belt sander, and then after that you'll have like a planetary head, or you'll have an orbital head, or one of each, to try to remove those cross grain scratches and to give you a scratch-free, swirl-free finish, basically. So, and then we also have brushing machines. So typically folks will call these denibbers, or they're used basically to denib parts, to clean parts up before they're painted. They're used to break the edges or round the edges in whitewood sanding, and then just to kind of clean up and finish any defects that you may have. So if they do a great job whitewood sanding and sealer sanding. They may do 70-80% of the job. So,
Is it possible to eliminate hand sanding altogether?
yes and no. Typically, the machines are going to eliminate 80 to 90% of it, but to achieve a really high quality finish, most customers are going to want to touch it to some degree. They're going to want to hand sand down in profiles, maybe the edges, to get a real good smooth finish. But yeah, the machine's going to do the majority of the work, but still it's necessary to touch it just a little bit. So yeah, one thing to keep in mind is the different grit levels. We kind of touched on it earlier when we were talking about the calibrator machine, the wide belt sander, but you're going to use coarse grits to remove more stock. You're going to typically on a wide belt machine, you're going to use a coarser grit on the harder rollers. But yeah, so typically whitewood sanding anywhere from 120 to 220 is what I've seen, usually 180, 220. And then your intercoat sanding, usually 280 to 400 with 320 kind of being the industry standard.
Is there any automation benefits for sanding?
Yeah, there are a lot of benefits for automating your sanding. I mean, it's reduced labor, reduced injuries, and shoulder injuries and elbow injuries and things like that. It's a hard job. You're going to get more throughput, higher production speeds, and then just a consistent product too, right? If you've got multiple people sanding, they're all going to sand differently. They're going to change paper more frequently than the other person. You're going to have more inconsistencies doing it by hand. So, all right. So the number 2 bottleneck that you're going to have is your spraying. So we can spray a lot of parts really quickly in these machines. We can spray, 3 parts, 4 parts wide, sometimes all across the belt. We're going to be more consistent. We're going to have different finishers finishing different ways. Applying different film thicknesses, doing things differently. It's going to help you with frequent color changes. It's going to help you with mixing the paint. We've got plural component mixers as well. So if you've got plural component products, conversion varnishes, urethanes, it's going to mix those products together on demand. So just less rework, less issues from manually having to handle the product.
Does automation also save in material cost? Okay,
yeah, it's going to help you with material costs. It's going to help you with your transfer efficiency, number one. You have better transfer efficiency numbers specifically in a flat line sprayer than you do hand spraying. So yeah, I mean, like I said earlier, you're going to have inconsistencies with different guys spraying. So if 4 wet mills is the target and this guy's spraying 5 consistently, he's doing 20% more work than he needs to be doing, putting more material on there than he needs to. So it'll make it more consistent and save money for sure. Yeah, so the main thing that automating the hand spraying does, obviously it helps you just spray more faster. Your production is going to go up. You're going to be able to spray a lot more parts quicker. You can load the belt up as densely as you can, and that's actually the goal, is to load it up as densely as you can and to make everything as efficient as possible. And you really get a lot of product through these machines. So definitely helps eliminate that bottleneck, or at least move it to another area of the shop. All right, and then bottleneck number 3 is a huge one, really. I mean, we can sand these parts really fast. We can spray a ton of parts in a short amount of time, but then we're left with lots of parts just sitting on racks drying, and we're beholden to the dry time of that product. We're not able to reprocess those parts until they're dry, until they're ready to be flipped or ready to be sanded. So automating the drying is huge, because it helps to automate sanding and spraying without drying, but it really doesn't do those two justice unless you automate the drying as well. And really be able to turn those parts around and reprocess them right away and keep a consistent throughput through that machine. Because if the sprayer's sitting idle or the sander's sitting idle, they're not doing what they were intended to do, and we've got a bottleneck somewhere. So ideally all 3 of those stages in the finishing room are consistently moving product through. So.
Bret, can you explain the different stages of drying?
Yeah, man. So we've got what I like to call dry to touch, or handleable, basically. So depending on what the customer's needs are, if they don't have the production demands where they need to, solve all those bottlenecks and continually be able to process those parts and rerun them back through the line, if they're wanting to just be able to get it dry to touch. So what we do is we'll run it through a laminar oven or something similar, and what we'll do is we'll accelerate the evaporation of the water or the solvent out of the coating, and we try to get it to where it's at least dry to the touch, where you can handle it gently, put it on a rack, and any dirt or debris that falls on that part, can be wiped off, cleaned off easily. You're not going to get trash in your finish, because one of the problems we see is parts coming off, you put them on a rack, and then you got a guy 10 feet away just sanding and blowing off doors, and all that trash falls into your finish. So it's critical, at least in my opinion, to at least get them dry to touch. If you're not getting them fully cured, ready to reprocess or ready to ship, at least get them dry to the touch. That way they can not be, damaged sitting on the rack, basically. Yeah. And if a real good solution for that too is not your conventional flat dry right out of the sprayer, but we've got a batch oven that we call our dry vault that you could take that rack of parts and just roll right into the room. So,
okay.
And then you have what's considered fully cured, right? So you've got UV curable coatings that are going to be fully cured out of the back of the machine, and then you've got a lot of other coatings that will be dry and able to be reprocessed, able to be sanded, but not fully cured and ready to ship. So, but what we try to do is we try to, take that reprocessing time. Say if a part needs to sit on a rack for an hour in ambient conditions, maybe we can take that hour and take that down to 10 minutes, right? 15 minutes, something like that, to be able to reprocess that part.
How do I know when it's good to sand?
Well, really by feel. You're going to be able to feel it. It's going to feel dry. You're also going to want to let it cool. If you're going into an oven, it's going to come out hot. What we refer to as the BST, the board surface temperature. Ideally, you let it get down below 85 degrees. You let it get to 85, 90 at the most, maybe, before you sand it. Even if they come out dry and they're still really warm, sometimes you can have issues sanding it. It can gum up on the paper, start to roll up in little balls, not powder up the way it's supposed to. But the number one way to test it is just try it. I mean, there are a lot of times where you feel like, maybe that's not ready, and we go over to the sanding table and we are able to sand it just fine. So just actually trying it and seeing it if it's ready. But like I mentioned earlier, you can, if it's an hour-long process, taking it down to a 10 or 15-minute process is huge for customers, right? So.
What are some of those automated solutions that we offer?
All right, we got a few different options. So we've got, I think I touched on the laminar oven. So what that is people will refer to that as a flash-off oven too, a lot of times. So that will go right after your sprayer. And what we're trying, it's relatively low heat and airflow compared to our other ovens, right? So what we want to do is we want to gently remove the solvent or water from the film of the coating. So when the coating is drying, the water or solvent is trying to evaporate, right? So we want to accelerate that process, but we don't want to do it so quickly that we film that coating over and that's still trying to escape the coating, right? So if we do that, then you have blistering, you have mud cracking, you're drying it too fast, right? So we want to push the boundaries of that and get it right to that edge of where it would fail, but not. So that way we're able to dry it as fast as we absolutely can. So when I was touching on dry to touch, that's a scenario where you'd use an oven like that, bring it out, okay, it's dry to touch, we can put it on a rack, but it's not fully cured. Maybe it's not fully ready to be sanded or flipped and reprocessed. If that's the case and you want to go to a more fully cured system, or something that's ready to be sanded right away, right off the end of the line, or flipped and ran back around, typically we would put another oven behind that, whether it be our jet air blade with more higher velocity air concentrated through these plenums, higher temperature in that oven. We also have IR capabilities, infrared. We could also go into a different type of infrared oven. We have catalytic IR, we have electric IR, or we could go into just a larger stacking oven, and what that is your typical convection heat, similar to your laminar oven, but just in a much bigger footprint, giving you the time that you need. So if you needed 20 minutes in an oven, we would get that in a big stacking oven where we go vertical instead of linear, to be able to get that time in that same smaller footprint. And then UV curing machines as well. So if you have a UV coating, you need UV lamps to cure that coating. It'll never dry if you don't, or it'll never cure if you don't. But the idea behind UV coatings is they're fully done when they come off the line. They're ready to be processed. They can be packed and shipped right away. So,
other than UV, how would a customer know which oven is best for them?
the best way to figure that out is to come in the lab and actually test it out in a real world scenario. We can guess from our past experiences, and we get pretty close. We get in the ballpark just by what we've done in the past, but to really dial it in and hammer it out, we really just need to do it and prove it out in the lab. So we'll know exactly what it takes to dry a particular coating, because depending on the substrate may be different, right? If we've dried this coating before, the amount we need to put on may be different. So there's always variables that are changing. So to make sure we're, doing our due diligence, we need to prove it out here first.
All right. You talked in a previous episode that many shops have automated other processes with CNC machines, but they left out the finishing departments, and they left it to hand spraying. Why is that?
I think years ago people they did invest in CNC machines and routers and things like that to help them on the woodworking side, on that end of the shop. And I think finishing has kind of always been the black art, the redheaded stepchild, right? Where folks typically will just trust and give that over to their finisher, right? Or their finishing operations manager, because it's something they don't know about, and they're maybe a little afraid of, intimidated by, and they don't understand the ins and outs of it. So they've always just kind of relied on the expert opinion of the people that they have around them to guide them. So I think now, there's less and less finishers in the world. Our generation isn't producing as many as the previous generation, so I think it's going to be critical that even these small shops start automating in the future. So.
Out of sanding, spraying, and drying, what usually causes the most delay?
The most delay? I would say sanding or drying. Drying, you're just standing around waiting on paint to dry, basically, and you can't reprocess them until that's done. I think one that causes a lot of frustration, though, for the business owners is sanding. It's very important to the quality of the finish, and also you typically are paying large amounts of people to stand around and sand, and it's a thankless job. It's a job most folks don't want to do, or they want to move away from that and get into doing something else. So if we can automate that and have them operating a machine instead of standing there sanding all day long, or move them to a different part in the production floor, it's better for everybody. All right, so in a future episode, we're going to try to dispel some of the myths and rumors about automated finishing, and answer any questions that may have come in the meantime. So if you're ready to take your finishing to the next step, please contact your Superfici America sales rep. Go on our website, watch tutorial videos. There's a lot of good information on there. And follow us on social media, and like us and subscribe on YouTube. So, all right, until next time, this is the Finishing Touch Podcast, helping you finish better.